Welcome back, everyone. In this video, I will now show you how to do a double linked list, which looks like, just a moment, please. This, here's what it looks like. This is what a doubly linked list looks like. Each node, in addition to its data, has a next field, which points to the next node in the list. Each node also has a previous field, which points to the previous node in the list. Naturally, the previous field for the first node will have none, and the next field for the last node will have none. Here's something we'll look at later. What you're looking at now is a circular linked list, but we'll talk about that later. Now, to create this in Python, the first thing you do is you must create a node class, which is right here. So here is its initialization function. Some data is being passed in as a parameter. So we have the data field, we have a previous field, and we have a next field. The data field is set equal to the parameter, and the previous and next fields are set to none. Now, when you create the double linked list class, in its initialization function, you'll have head, which will point to the first node in the list, but you also will need another pointer called tail. Tail will point to the last node in the list. We're also going to have a size parameter, which of course is initialized to 0, since there's nothing in the list yet. Now, here is a getSize function that will return the size. Size being, of course, how many nodes are in the list. I have two insert methods. I'm going to focus on the second one first. I'm going to point you to this one, insert at tail. Okay, so suppose you want to add a node to the end of this list. So the first thing we do is we create a new node by using the node class's initialization function. So there's the new node, but it hasn't been put into the list yet. So the first thing you do is you check if your list is empty. That's what this if condition is for. If head is none. If head is not pointing to anything, there's nothing in the list yet. So that's empty. So if that's the case, you set head and tail equal to the new node. So let's look at what that would look like. Yes, fair warning, I'm going to draw something. Okay, so here is head. Here is tail. Here is our first node. Let's say it has a 1 in its data field, and we have none in both the previous and next fields. If this is the first node in the list, then head will point to this node, and tail will also point to this node. There we go. Now suppose we want to add a second node to this list. I'll put it right here. So we'll say 2 for the data, previous, and none for the next. So in this case, head is not none when we create this second node. So we come to the else. Here. And the first thing we're going to do is we're going to say new node's previous is equal to tail. This means the new node's previous field will point to whatever tail is pointing to. Tail is currently pointing to the node that has the 1. So get rid of the word none there, and the previous will go there. That's the first thing. The next thing, we'll say that self tail dot next is new node. Tail is still pointing to the node that has a 1. So that means that node's next field will no longer be none. It will point to the new node we just made. And finally, we say that self tail is new node. That means tail no longer points to the node with a 1. It points to the node with a 2. That is how you add a node to the tail or end of a doubly linked list. Now then, since we've done all that, let's now look at how you would add a node to the head or beginning of the list. That is this function right here. So let's say we want to add a node to the head. I will put it right here. You first create the new node here by calling the node class's initializer. I'll give this a 3. And this node, of course, has none in the previous field and none in the next field. Once again, no matter where you're inserting, you first check if head is none. If there, in other words, if you have an empty list. Well, clearly we don't in this case. If we did, we'd set both head and tail to this new node. But as you can see by my drawing, head is not none. We do not have an empty list. So we're going to go jump. We're going to jump directly to the else. Here's what we're going to do. First, we say the next field of the new node is head. So that means next field is no longer none. It points to this next node in the list. The next thing we do is we say self head previous is new node. Head is still pointing to the node with a 1. So that means this field will no longer have none. It will point back to the node that has a 3. And finally, head now becomes new node. That means head no longer points to the node with a 1. It points to the node with a 3. There you have an example of adding a node to the head or beginning of a double linked list. The last function I'm going to show you is this one called print list forward. This will print every node in the list from beginning to end. Now, at this point, you might ask yourself, well, isn't it also possible to print the list in reverse? Yes, it is. Let's just say, I'm going to leave it to you to figure out how to do that. Hint, hint. In the meantime, let's see what happens. Well, once again, we have our old friend temp. So if we're going to print the whole list, we're going to have another pointer named temp. And temp will point to head. More accurately, the same node that head points to. So there we go. Now we print out a message saying, here is your list. And now we go into a while loop saying, while temp is not none, the first thing we'll do is print temp.data. So print the data field of the node temp is pointing to. In this case, we would print the 3. And then we say temp is equal to temp.next. So that means we set temp equal to the next field of whatever temp is pointing to. Temp's pointing to here, and this node is pointing to the node with the 1. So temp will no longer point there. Temp's going to point there. And we print the 1. And now we say, well, temp is not none. Well, print it, and temp equal temp.next. So now temp no longer points there. Temp points to the node with the 2. We print the 2. But now when we say temp equal temp.next, the 2's next field is none. So that means now temp is none. And that means the while loop ends. And that's how you print the list. All right, let's run this and see how it works. I'm going to have to erase my artwork now. Sorry, folks. Right, like it'll be missed. Okay, anyway, here is main. So to start us off, I'm going to declare an object of the double linked list class, doing that right here, calling it DL. And I'm doing 3 insert at tails. Insert a 1, insert a 2, insert a 3. Then I print the size of the list and print the whole list. So when I do that, here's what I get. Size of the list is 3, and there's my list, 1, 2, 3. Now then, however, I'm going to uncomment all of these lines, and let's see what this does. Okay, 2 blank lines I print, and now I'm calling insert at head 6 times, and I'm inserting numbers from 44 through 99. And then I'll print the size of the list and print the list. Let's see what I get. Okay, there's my previous one. Size of list is 3, and my list is 1, 2, 3. And now, after doing the 6 insert at head function calls, the size of my list is 9, and look at my list. Remember, when you call insert at head, you're inserting the new nodes at the beginning. That's why when I'm all done with those, 99 is the first number. Because first 44 is inserted, then 55, then 66, and 77, all the way to 99. And that's why my list looks like that. There you have your first example of a doubly linked list in Python. If you have any questions, please send me an email at kmuldrow@lbcc.edu.